Good morning, ma'am. My name is Azad, pursuing final year BTech in the stream of Electrical and Electronics Engineering. Today, my topic is illumination. We are going to discuss the contents of the topic of illumination. First, we are going to see definition for light, definition for luminous flux, definition for luminous efficiency, definition for illuminance, phase angle and solid angle relationship, luminous intensity, and what are the laws of illumination. First, light. Light is a form of electromagnetic radiation emitted by a body which produces a visual sensation upon the human eye. It is expressed in the lumen watt or analog to watt hour. This type of energy is emitted by the body depends upon the temperature of the body. The heat on the body can be classified as red hot or white hot. When the body is red hot, 500 degrees centigrade to 800 degrees centigrade is available in the form of heat only. When the temperature increases, the body changes from red hot to white hot state. 2500 centigrade to 3000 centigrade. The wavelength of the energy radiate becomes smaller and enters into the range of wavelength of the light. The wavelength of the heat is greater than the light. Here we can see how the gamma rays and how the radio waves are there. Gamma rays are short, having shortest wavelength. Radio waves are having longest wavelength. The units for wavelength are in meters or angstrom. Sensation of human eye is maximum at 5500 angstrom. Then next, luminous flux. It is the amount of light radiated by the light per second. The unit of luminous flux is lumen. The symbol is phi. It does not specify the direction in which the light is radiated. Lumen can be defined as the light energy radiated by the source of 1 by 685 watts and has wavelength of 5500 angstrom. That is clearly mentioned luminous flux in the figure. Luminous efficiency. The ratio between the luminous flux of a lamp and the power consumed in that lamp is termed as luminous efficiency and is expressed in lumen per watt. For incandescent lamp, luminous efficiency will be 10 lumen per watt. For fluorescent lamp, 100 lumen per watt. For low pressure sodium lamp, 200 lumen per watt. Next, coming to the illuminance topic. It is the quantity of light or luminous flux falling on the unit area of the surface. The unit of illuminance is lumen per meter square or lux. In summer season, under a clear sky, the illumination is about 1 lakh lux. In partial cloud area, the illumination is about 5000 lux. The artificial lights in office, the illumination is about 500 lux. Full moon on a clear night, the illumination is about 0.25 lux. Next, phase angle. Phase angle is denoted by theta, an angle subtended at a point in a plane by two converging straight lines, and its magnitude is given by theta is equal to arc by radius and is measured in radians. The largest angle subtended at the point is 2t. It is dimensionless quantity. Next topic, side angle. Solid angle. Solid angle is the angle generated by the surface passing through the point in space and the periphery of the area. Solid angle is denoted by omega. Solid angle units for solid angle is steradians. Solid angle is given by the ratio of the area of the surface to the square of the distance between the area and the point. Omega is equal to area per radius square. For sphere, solid angle is omega is equal to 4 pi r square by r square, that is equal to 4 pi. For circle, the solid angle is pi. The relation between the phase angle and plane angle and solid angle is, for example, consider a curved surface, spherical segment of the height h and radius r. Surface area of such a segment is 2 pi r h. By doing that, surface area of the segment will become 2 pi r h is equal to 2 pi r square. H value is 1 minus cos alpha by 2. Then side angle will be 2 pi 1 minus cos theta. Then sin cos by 2 is equal to cos theta. Then coming to the luminous intensity. Luminous intensity is an given direction in the luminous flux emitted by the source per unit solid angle, that is omega, measured in the direction in which the intensity is required. The solid angle is shown by luminous intensity figure. It is denoted by capital I and it is measured in lumen by steradian or candela. Luminous intensities in a given direction is luminous intensity I is equal to luminous flux by solid angle. If the source is isotropic, total luminous flux being spread in a solid angle 4 pi uniformly in all directions. Luminous intensity is given as with respect to through the isotropic source 5 by 4 pi. Luminous intensity I is equal to 5 by 4 pi. It is, the units are candela. Laws of illuminations. Here in laws of illumination, it consists of two laws: inverse square law, Lambert's cosine law. First we are going to study inverse square law. The statement for inverse square law. It states that the illumination of a surface is inversely proportional to the square of the distance between the surface and a light source, provided the light source is point source. Here the figure is clearly mentioned in that S is equal to point source, A1, A2, A3 are the parallel surface areas, R2, R3 are the distance of surface areas, and I will be the luminous intensity, omega is an solid angle, luminous flux phi1 on area 1, luminous intensity into solid angle will gives us a illumination on surface. Then we are going to see here values of E1, E2. E1 that is nothing but 1 by r square lux. E2 is equal to 1 by 2r square lux. Yeah. Then these are all E1, E2, E3. That will be the inverse square law. That is here clearly mentioned inverse square law. Clearly mentioned how the light fall also happens. Next we are seeing that Lambert's cosine law statement. It states that the illumination E at a point on the each surface is directly proportional to the cosine of the angle between the normal to at that end and the line of flux. In figure, they clearly mentioned the how Lambert's cosine law happens. Next, the formula for Lambert's cosine law is EQ is equal to 1 by h square cos theta. That will be considered as an equation 1. Then E suffix q is equal to 1 by h square. It is a point q. The angle theta becomes 0. Therefore, cos theta will becomes 1. ER is equal to 1 by r square cos theta. It is considered as an equation 2. Here, cos theta is equal to 1 by r into h by 1, that is nothing but h by r. Then cos square theta is equal to h cube by r cube. Multiply and divide above equations 1 and 2 equations with the h square. Then we get h cube by r cube is equal to cos cube theta. Lambert's cosine law is also equal to cos square theta law, cos cube theta law. Thank you for giving this opportunity.